So, have a look at question 1. We'll come on to question 2 in just a second, because I just wanted to see kind of if you could employ any strategies with question 2. So question 1 should be a bit of a revision on what we were doing last lesson, right? So I give you a curve. What type of curve is this? Y equals third x cubed plus 2x squared plus 3x plus 5. It's a cubic curve, okay? So how many stationary points are we expecting? It's a cubic curve. You should be expecting 2. Remember, you can get away with 1, okay, if it's a special type of cubic curve. But in general, we're expecting 2, okay? So part A, we need to find the stationary points. How do we do that?
We start by differentiation.
Okay, so first things first, we need to differentiate this thing. So if we differentiate this thing, what do we get?
X squared.
Good, because remember, you bring the power down, so it becomes a third times 3, which is 1. X squared, sorry, plus
4x.
Yeah.
Plus 3.
Plus 3. Perfect, okay? Then what do we do once we differentiated it?
We try to find the x by setting it equal to 0.
Good, exactly, because remember, what does this thing represent again? It's the gradient function, yeah. So you are looking for the stationary points. In other words, where does the gradient equal 0, okay? So I would say a stationary point will occur when dy by dx, my gradient function, is equal to 0. Remember, I advise writing that bit down because then it shows me that you know what you're talking about, okay? So this is my gradient function, x squared plus 4x plus 3. So I set that equal to 0, and then I solve it. How do I solve this? So that's your roots, perfect. So I go for factorising. This is just a quadratic. We know how to solve this, so it should be plus 3 and plus 1, which means that x has got to be negative 3 or x has got to be equal to negative 1. Have I finished with part A? No. What do I need to do now? I need to find y. I'm after a stationary point, right? So I'm after an x and a corresponding y. So how do I find it? Into? Well, which equation? So which one?
The first one.
Yeah, the first one. Remember, this is my gradient function. Not interested in that because that's just going to give me 0. I need to stick it in this one because this one says you give me the x and I find the corresponding y. Make sense? Yeah. Okay, so if I stick, well, let's stick negative 3 in first. So if I stick negative 3 in here, what do I get?
We get 5.
We get 5, okay. Remember, you can stick that in your calculator if you wish, okay? However, if you stick it in your calculator and you type a wrong button or it comes out as wrong, then I can't give you any marks for this. So to be on the safe side, what I would advise you doing is show me that you're putting it in this equation, okay? So I'd write a third times by negative 3 cubed plus 2 times by negative 3 squared plus 3 times by negative 3 plus 5. Okay, so just show me that what you're doing and then I can give you a mark for it, okay? But yeah, okay, I'll believe you, it comes out as 5. So my first stationary point is negative 3, 5. Did everybody get that? Okay, let's do another one then. So let's do the x equals negative 1. So similar kind of thing, I stick it into my equation. First, show me what you're doing, so 2 times negative 1 squared plus 3 times by negative 1 plus 5. What does this come out as, somebody?
5. Negative 1 comes out 11 over 3.
11 over 3. Okay. So therefore my stationary points are going to be negative 1, 11 over 3, and the other one which I found, which was negative 3, 5. Does that make sense to everyone? Did everybody get that? So that's one stationary point, that's another stationary point. Any question about part A? Is it all okay? Perfect. Okay, so let's have a look at part B. Part B, we just take it a little bit further. We need to determine the nature of the stationary points. Now just remind me, what am I literally asking there if I'm asking to determine the nature?
It's minimum or maximum.
Perfect, minimum or maximum. Do you remember we discussed that there was a third possibility as well?
Yeah, I remember.
Let's look back in your notes if you're not sure. So it's either a minimum, a maximum. What's that third possibility? It's a point of inflection. Perfect. So here we go. We can either have a maximum, we can have a minimum, or we could have a point of inflection. Okay? Point of inflection. It kind of comes to a rest and then kind of carries on. Does that make sense? Okay, good. So how do we determine the nature of the stationary points?
If it's negative, it's.
If what is?
Oh, if it's if the x or is the y.
We need to differentiate again, you remember? This thing gives us our gradient function, what we found in part A. This gives our gradient function, but now what we're talking about is the function decreasing, increasing, or doing this thing where it's doing both, okay? So we need to find the rate of change of the gradients. In other words, we need to differentiate the gradient function, okay? So we need to differentiate the gradient function, which we write like this, d2y over dx squared. Okay? So if we differentiate the gradient function, what do we get?
X, 2x.
Yep, 2x plus 4. We literally just differentiate this again, okay? So this is now telling us how our gradient is changing, rate of change of our gradient. So what we need to do is we need to consider each point. Okay, we need to consider each stationary point to find out what's happening at that stationary point. So let's go for the first one we found. So let's go at negative 3, 5. Okay, what's the rate of change of our gradient at negative 3, 5?
Negative 2.
Yeah, good. Just simply stick negative 3, our x value, in here. So it comes out as negative 2. Now you know then, at the point negative 3, 5, the rate of change of our gradient is negative. In other words, it's decreasing, so it must be a maximum. Okay? So it must be a maximum. Okay? Does that make sense? In fact, I would put an extra thing here. I would say d2y by dx squared is decreasing, or less than 0, negative, so therefore it must be a maximum. Okay, show me how you deduce that. Does that make sense? So literally just put that there. Okay? All right, let's do it again. So let's go at negative 111 over 3. Okay, negative 111 over 3. What's the rate of change of our gradients doing? What's d2y by dx squared?
2x.
Yeah, so 2x plus 4, so we need to stick what value in there?
Negative 1.
Negative 1, we need to stick our x value in. So we get negative 2 plus 4, that comes out as 2, okay? So therefore we can deduce that at negative 111 over 3, the rate of change of our gradients is positive. In other words, it's increasing, which means it must be a minimum. Perfect. Does that make sense to everyone? Yeah? Does that make sense? What would the situation for the rate of change of our gradients have to be for a point of inflection?
Is there that's another x?
So this thing was a maximum, which means that the rate of change of our gradients was decreasing. In other words, it was getting smaller.
Equal to 0.
Yeah, for a minimum, the rate of change of our gradients was increasing. In other words, it was greater than 0. For a point of inflection, it's increasing then decreasing, or decreasing then increasing. Yeah? So therefore, the rate of change of our gradients is, if you like, another stationary point. It's not changing. Yeah? In other words, it's equal to 0. Okay? But yeah, don't worry too much about that. It's very unlikely that I'm going to ask you about points of inflection in the exam, but just be aware of it. Okay? Just be aware of it. Are there any questions about this? Yes. Any questions about this? No? You can, if you wanted to, you can think of this almost like a recipe. Okay, so when you find your stationary points, what's the first thing we need to do? Differentiate. Okay, then what do we need to do?
Put the x equal to 0.
Set it equal to 0, finding the point where the gradient is equal to 0. Then what do we need to do? Yeah, solve it, find x. Okay, then what do we need to do? Find y. Okay, that's enough to find our stationary points, a 4-step process, right? And then if you want to find the nature, you can carry on going. So what do you need to do if you need to find the nature? Differentiate again. Okay, then what do you need to do? Yeah, you put the x value of your stationary point in there. That's the 6th thing. Okay, then what do you need to do? Is that less than 0, greater than 0, and equal to 0? Then you can make your deduction. So if you like, it's basically a 7-step process. Now feel free to just remember the recipe. However, if you want to be a mathematician, think about what's actually happening here. So you notice when I'm talking it through, I'm literally saying, well look, I need to first of all find my gradient function. I don't just remember to find a stationary point you differentiate. I'm thinking, why do you differentiate? Because to find the gradient function, you know that a stationary point occurs when the gradient is equal to 0. That's why you set it equal to 0. And then from there you can find your x values, and of course you need a point, so you need to find your y values as well. And then if you want to find your nature, you're thinking, well nature just means, is it a maximum, minimum, or point of inflection? In other words, what is the rate of change of our gradient doing? Is it increasing, is it decreasing, or is it equal to 0? And then from there you can make your deductions, okay? So you've got two options, either just remember the recipe, or do what I do and actually think through what's happening. Does that make sense? Good, excellent.